Hi, welcome to Pathways to Chemistry. This is Dr. O'Connor. Here we're asked how many moles of arsine gas occupy 0.04 liters at standard temperature and pressure. What is the density of the gas? Well, first let's go ahead and define standard temperature and pressure. So at standard temperature and pressure, we have a pressure of 1 atmosphere and a temperature equal to 273 Kelvin. Now, the first thing we need to do is solve the ideal gas law for moles. So let's go ahead and do that. So N is going to be equal to PV over RT. And in this case, R is 0.0821 liters atmospheres per mole Kelvin. Okay, let me make sure that my units are in agreement with the constant. So we have volume in liters, of course, pressure in atmospheres, and temperature in Kelvin. So we're all set to go. So let's go ahead and solve this then for the number of moles. So that's the pressure, which is 1 atmosphere, times the volume, which is 0.04 liters. And we're going to divide that by the ideal gas constant, 0.0821. Okay, it's always a good idea to keep track of your units. That way, if they're not canceling out the way they should, then you know that something's wrong. And that's 273 Kelvin. So let's see what happens here. Atmospheres cancel, my volume cancels, the Kelvin cancels, and we're left in moles. So I go ahead and plug that into my calculator, and I end up with 1.78 times 10 to the negative 3 moles of arsine. Now remember that standard temperature and pressure, 1 atmosphere and 273 Kelvin, these are exact numbers, so they're not going to affect the number of significant figures. Now what I can do is I can convert the moles of arsine to the mass. So the molar mass of arsine, again, I just look up the molar mass of arsenic and hydrogen, and the molar mass is equal to 77.94 grams per mole. So I can determine the mass from this. So the mass of the arsine is going to be equal to 1.78 times 10 to the negative 3 moles. And we know that 1 mole of arsine is 77.94 grams. So that's going to give us 0.1391 grams of the arsine. Well, we have the mass and we have the volume, and density, of course, is mass over volume. So we have 0.1391 grams. We divide that by the volume of 0.04 liters, and that is going to give us 3.48 grams per liter.